Exposed to the wind and rain, this iron signpost is slowly rusting away. It's corroding. Corrosion can spell ruin to many things, including what could be your most valuable possession. Cars are made from mild steel, which is a form of iron. When exposed to the atmosphere, the iron reacts with water and oxygen in the air to form iron oxide, a material commonly known as rust. Corrosion of iron and steel is a nuisance, and a lot of engineering effort goes into trying to stop it, or at least slow it down. Here, on the roof of the British Steel Research Laboratories in London, tests are being made on two specially made steel assemblies. Each assembly has been designed differently to see what effect design has on the rate of corrosion. After 15 years in the wind and rain, the sides of this box have almost completely corroded. It's been designed in such a way that every time it rains, water is trapped inside. The other assembly has been exposed for exactly the same time. A similar box here has a hole in the bottom, and it survived. There are other features on this assembly which provide traps for water and a site for rapid corrosion. Water running down this support can get into the joint, and it doesn't matter how tightly you bolt them together. But by lapping the steel the other way round, we can prevent this from happening and slow down the rate of corrosion. Here's another joint where water can collect and corrosion has occurred. Now these two pieces of steel have been bolted together. By welding them together, we not only prevent water getting into the joint, we get rid of the crevice. Most metals will oxidize when they're exposed to the air. This statue is made from aluminium. It's been in London's Piccadilly Circus for 80 years, but so far there's little sign of corrosion. This train is also made of aluminium. When exposed to the air, aluminium forms a layer of oxide which stops any more oxygen from getting at the metal. If you bend a piece of aluminium, you can sometimes see the oxide film breaking. Now, the layer of oxide on this piece of aluminium has been deliberately thickened by a process known as anodizing. To do this, the aluminium surface must first be thoroughly cleaned, in this case, chemically. By treating the aluminium in hot acid for a few minutes, we get rid of any grease or dirt on the surface. The components must then be rinsed in water. The aluminium is then treated in an alkaline solution purely and simply for decorative purposes. This is followed by another water rinse. Once cleaned, the aluminium is treated electrochemically. For this, it's immersed in a bath of dilute sulfuric acid and connected electrically to the positive side of a direct current supply. When the current's switched on, it causes a hard film of oxide to form on the surface of the aluminium. Anodizing is a form of controlled corrosion, which prevents any more oxygen from getting at the surface. Now, the iron oxide, or rust, that forms on steel doesn't stop oxygen getting at the metal. It's porous. So, unprotected, steel will continue to rust. One way of protecting steel components like these is to coat them with a layer of metal that's not affected by air or water. These railings have been coated with zinc in a process known as galvanizing. Before galvanizing, the steel railings must be thoroughly cleaned. This is done by pickling the steel in a bath of hot sulfuric acid. The railings travel through the bath, and in the process, all the rust is removed. The railings are left in the acid for about 20 minutes. Then they're rinsed in hot water. Next, they're dipped into a liquid called a flux. This flux will keep the surface of the steel free of oxide during the coating process. Watched carefully from behind a screen made of safety glass, the railings are dipped into a bath of molten zinc. They're lowered very slowly, as there's always a danger of molten metal being thrown out of the bath. The temperature of the zinc is between 450 and 465 degrees centigrade. Before the components are withdrawn, an ash which forms on the surface of the molten zinc must be skimmed back. Now, on the surface of the railings, the zinc forms an alloy with the iron in the steel, and on top of the alloy, there's a layer of zinc. Galvanizing is a relatively cheap and easy way of protecting all sorts of iron and steel components, which are exposed to the atmosphere. If you look on the surface of a piece of galvanized steel, you'll often see a series of light and dark patches. Can you think what they are? Besides zinc, there are other metals that are used to protect steel, and there are other ways of applying them. Here, we're coating a mild steel strip with tin by an electrochemical process. The strip is a continuous string of pre-formed parts. First, it's degreased by passing it through a suitable degreasing solvent. Next, it's washed in cold running water. It's then pickled. This will remove any remaining grease and any oxide, such as rust, which may be on the surface of the steel. After washing again, the steel goes through another solution which prepares it for coating. Now, before coating this particular strip with tin, the customer wants it coated with copper. This is done electrically in this bath. The steel is connected to the negative terminal of a direct current supply. Hanging in the bath are two pieces of copper, which are suspended from a brass rod. The copper is connected to the positive terminal of the same supply. As the current travels through the bath, an electrochemical reaction occurs in which metal is transferred from the copper to the steel. The steel is now coated with copper and goes off to be rinsed before being coated in tin. The tin coating is done in this bath in a very similar way to the copper coating. Let's look at the idea in a diagram. The strip travels through a bath of tin sulfate. Also in the bath are large slabs of tin, each contained in a special porous bag. The tin is connected to the positive terminal of a direct current supply. In electrical terms, it's called an anode. The steel strip is connected to the negative terminal of the same supply. Here is one of the tin anodes. And this is where the steel strip is connected to the supply. The current causes tin to be deposited onto the previously coated copper strip. If you can, compare the effect of scratching steel coated with tin and steel coated with zinc. Cars are exposed to all sorts of corrosive conditions, especially in winter. For protection, the mild steel from which they're made is coated with paint. This sample of mild steel is the sort of condition the bodywork of a car is in when it arrives in the paint shop. It's covered in grease. Can you think why? Let's give it a coat of paint. Dipping is a very quick and effective way of painting a material. Now, in the laboratory, we can quickly find out how effective this coating is against corrosion. When the paint is completely dry, a scratch mark is made through the paint down to the metal. The sample, together with other samples, is then put into this special chamber where it's sprayed with salt water for anything up to 2 weeks. Let's have a look at the result. It's not very good. The paint has failed to adhere to the surface of the steel and the rust has spread underneath it. Let's test another sample, but this time we'll degrease it first. Here the sample is suspended in a vapor of degreasing solvent. As the vapor condenses on the metal, it removes the grease. After painting and testing, this is the result. It's still badly corroded. The paint still hasn't adhered to the metal properly. Now we can improve the adhesion between paint and steel by modifying the surface of the steel. This is done chemically by dipping the steel into a warm solution of zinc or iron phosphate. After a time, a chemical reaction starts up. The phosphate reacts with the surface of the steel and a phosphate coating is formed. If we compare this with a steel sample that hasn't been coated, you can just see the difference. If we take a much closer look at the coating, you see phosphate crystals. This coating not only provides a key for the paint, it also gives added protection to the steel. Here's the result after painting and testing. This time the paint has adhered to the surface and the rust hasn't got underneath. Before cars are painted, the steel is treated in a very similar way. After degreasing, the bodies are completely sprayed with a phosphate solution which forms a coating on the steel. They're then sprayed with acid. This seals the phosphate coating. Before painting, the bodies go through a very high temperature oven. Each body is then dipped up to the waist to give it the first coat of paint, called a primer. Can you think why they don't need to dip the upper part? After all the joins are sealed, the bodies are then given 2 coats of an epoxy primer surfacer. Before it's ready for the road, the steel will be painted up to 11 more times. For heavier steel work like lampposts, a coating of plastics material offers an alternative to paint. Once again, it's the surface preparation that's important. On arrival at the factory, the steel posts are usually covered with rust. This rust is removed by shot blasting. The post is held between travelling centres, rotated and passed through a steel cabinet. Inside, the post is bombarded with thousands of tiny iron pellets at a very high velocity. The result is a cleaned and roughened surface which is now ready for coating. The steel posts are then fed into an oven to be heated to a temperature of about 350 degrees centigrade. Once the steel has reached the right temperature, it's coated with a special adhesive. This helps to produce a strong bond between the steel and the coating that's going to be applied. Now, the plastics material used for coating is in the form of a very fine powder. Air is blown through the powder, producing what is known as a fluidized bed. The prepared column is then dipped into the bed. The heat from the steel melts the powder, which forms a smooth, uniform coating. After coating, the post is quenched in water. This gives the plastics material a hard, glossy finish. This type of coating is very tough. It also needs little or no maintenance, and that's an important factor where cost is concerned.